Hi everyone, welcome back to another session on Databricks. So today we will talk about the transaction log part 2, which is a continuing session from the previous part 1. Who didn't go to the previous session, please go back and go to the video. I'll provide the video down below, then come back here. So those who have already gone through the previous video, let's get started. So transaction log, as I told you in the previous session, that captures each and every transaction happened on the data file, right? So whenever user modify or do any kind of operation, Delta breaks that operation down into a series of discrete steps composed of one or more of the actions like add file, adding the data file, then remove the previous file. So when I say remove the previous file, it just remove the association of this data file to the table, right? So instead of modifying the old file, it will copy or modify all the transaction that user is doing into the new file. Then it may require the metadata updates like changing the column name, data type, etc. Then for the transaction, it set the transaction with given ID. Then next is the change protocol that enables new features by switching the Delta Lake transaction log into the newest software protocol. Then finally, it is the commit information. So which operation was made from where and at what time, all these informations are captured together. Then all this information recorded in the transaction log. Now let's look at the example on the right hand side I given. So let's say the user is inserting some records and it generated two Parquet files, Parquet1 and Parquet2. These two files is associated to the data table, right? So these two files will be added here in the JSON file. Then next time when the user updates the records in the same table, what happens is it create another JSON file 001.json and it delete Parquet1 and Parquet2 that is created at the time of the first operation and add the new file. So any data that you are updating, what it will do is it will capture the entire data from the first two files, then modify the records and store it in the next file. So it's not going to update the existing data file, right? So the JSON file that opened newly for logging the transaction log details, it will remove the old files and add the new file association here. So now when you look at the delta table, you can see that the file is associated, only Parquet3 is associated with the table. So by default, it can keep 7 days of records when you do the vacuum, and you can control that, how many days of history you need to keep it, and you can go back based on that settings, right? Anyway, and the user, again, if he try to modify the file update 2, then what happens is it create another JSON2 file and repeat the same steps that I explained before. It will remove the previous file association and add the new file Parquet4. So that will keep on continue, right? So let's say now too much updates or insert are happening. Then what will happen is every 10th commitment, Databricks open up a checkpoint so that it will save the entire state of the table at point in time. right? The benefit of this one is, let's say your session is committing up to 5th, and there are a lot of other users also working on the same table and do the commitment, right? So what happens is, whenever it has to refer, it doesn't want to go back and refer sequentially. Instead, it can go back and check the last commit point, the checkpoint, and from there it can start reading. So if your session is here and the other users are committed up to 10th, then this will not read from 5, 6, 7, 8, 9, 10, sorry, 9. Instead, it directly jump into the 10th checkpoint, get the table state, then from there again it will update 11 and 12, right? So again it will go till another 10, the 20th checkpoint, 20th commitment, again it will create another checkpoint. So this will improve the performance also. So this is how the multiple updates happening. So what it will do is, so let's say there are multiple users, right? So it run as an optimistic control, meaning if the user are not using the same data point or data block, then all other data block can be committed at a time. But if you look at this example, there are 3 users, and this user, the first user is using data block this one, and the last one, these two are independent, it's not using by other users. And the next second user, it is using the second data point and the 4th one, but I'm colored this as a red color, right? Because the 3rd user also accessing this data point. So what happens is, at the time of commitment, it will check any update happened on this data set, and usually one person can win over the other, right? It will try to attempt to commit, find out that there is another update happened on the same block. Then what happens is, internally Databricks internally try to wait for some time and commit again, right? In case it's not happened, then it will throw an error. So this is how the read and write is happening in a multi user environment. So this keep on check what are the data blocks it is trying to use by multiple users, and if it finds any conflicts, it provide advantage to one person and wait for another, and internally it will update. If it is not able to update, then it throw error, else it will commit. So this cycle will continue, and that's how Databricks handles the concurrency. And now it is the time for demo, right? So I'm using the same file that I used in a previous transaction log part 1. So let's see what are the files I'm going to use. So we have a msft.csv file, right? Now if you look at here, I just created a delta tran folder, and we'll be creating the delta table in this folder, right? So let's see whether we have any data here. It's blank, nothing is there. This statement I don't need to execute, it's already executed, the folder is there. Now I'm going to read this CSV file and converting that into delta table, right? So before that I just renamed adj space close to adj close. That will be easy for me to while creating the delta table. Now this data frame, I'm going to write it in this table in a delta format. Okay, so when I execute this, and the table I already created, you don't need to create it again, it's in the same path. So let's check the data now. All right, so you have all the data from this data frame, right? Now look at the transaction log files. So you can see that there are two files created. One is CRC and the JSON file, right? So let's take the data of JSON file and see what exactly we have it in this file. So let's copy this and execute. So you can see these are the commit info. We have it, right? What is the cluster ID, engine information, then all this data, right? Notebook ID, which notebook ID it loaded the data, then operation parameters, whether it is an override, what is the timestamp, who executed this, all these details will be there in the commit info, right? And the metadata, right? So these are the metadata, the table name, the data type name, partition, if any, all these details will be captured here. And if you look at here, this the other details like data change equal to true, what exactly the part data file, this is the data file I was talking about, right? So only one file is there for now, only one file or multiple file. Let's go and check, right? Give me a minute. So fs.ls, let's okay, we'll take new field and execute it here. So let's just add one more and come here. Yeah, so you have only one file. So this file association is there in the JSON file, right? Now what we can do, let's update the file. Now you can see update the table, not the file, sorry. So let's execute this. All right, so only one row affected, that's fine. And now we can execute how it generated, right? So now you can see that there are two Parquet files, this one and the first one. Let me find out which one is the latest one. Okay, so the first one is 5986. So here you can see 5986. So this is the first one, this is the latest file, right? Now we have to go back and check the delta log. Let's execute this and we see this is the first one JSON file, this is the second one, right? Now we can check what happened to this. Let me copy this, paste it here, just display it. So look at this one, right? So the association is with a new file, the old file is not there, right? But you can see both the files are available here. So whenever new update or changes happens, then it will keep on add new file, right? This is required in case if you want to go back the previous updates and revert it back in case the new update is bad or corrupted or anything, you can revert it back, right? Now you have to, okay, I can show one more thing, the checkpoint one, right? So let's execute this one multiple times. So let's see what happens. Again, I can show once again. So it added one more file, 191, I think. So let's go back here and check the delta log. So you can see that another file added, that's fine, it's the same thing. Now I'm just going to keep on update 10 times and see what happens. So let's back in here, this is third time. Third time commit, and this is fourth. 5th. Okay, 7, 8, 9, finally 10. Okay, so now let's come here, check how many files we have it now. Yeah, so we have so many files, right? So every commit, it will have a new file associated. Now if you look at here, delta log, what happens is it should generate the checkpoint file, right? So let's see, where is the checkpoint file? I'm not seeing the checkpoint file. So on, okay, only 9 it came. Okay, let's do it once again. See, all right, let's execute the log file again. Not this one, log. Okay. Okay. Here. All right. So yes. So you can see the checkpoint file. This is the checkpoint file where, sorry, this is the checkpoint parquet file. It will store the entire table status, table state, not the status, state. So as I described before, so any update happened in your session on 5 and other users are committed 6, 7, 8, 9, 10, and when you are trying to do something, it doesn't need to read it from 6, 7, 8 sequentially. Instead it will always check the checkpoint and directly jump into the checkpoint file. All right, so this is what I want to share in this session. If you have any question, please comment below and I'll get back to you. All right, thank you everyone for seeing this video, and see you next time. If you would like to receive more such videos, please like and subscribe to my channel. Also, if you would like to connect with me, I have provided my details here, my email and LinkedIn. So thank you very much.